So in this video, we're going to take a look at the law of sines. Before we do that, I want to think back just a little bit here. Normally, when we think about the trig functions, sine, cosine, tangent, we think about using them in right triangles. That's how they were defined earlier in the course. Right now, though, we're going to start studying triangles without right angles, and a triangle without a right angle is called an oblique triangle. So an oblique triangle might look something like this, where we could possibly now have an obtuse angle like that, and we'll connect with the longer side there. Generally, I'll label them the same way each time, no matter what given information. I generally draw the same picture, where we'll call this alpha, beta, gamma. Opposite alpha, I'll call that A. Opposite beta, I'll call that B. And opposite gamma, I'll call that one C. Now, again, without a right angle in here, it's actually now gonna need to be solved using a different technique than we've studied in the past. So to do this, we'll go ahead and we'll create now the law of sines. So the law of sines, in order to get this thing going, what I'm going to have to do first is actually go ahead and construct a couple of right triangles. Maybe I'll call this one height 1, and over here I'll call this one height 2. So by dividing it and creating it the way I have, we're actually going to now be able to focus on certain parts. So the first part I'm going to look at here is this triangle right here. So that triangle there, and if I want to know sine of alpha, you can see sine of alpha would now be h1 over b. And now focusing on this triangle right here, sine of beta would now be h1 over a. So I'll take both of these now and I'll solve them for h1. So h1 would be b sine alpha. h1 over here would be a sine beta. And since both are equal to h1, we can set them equal to each other. So b sine alpha equals a sine beta. Dividing by a and b, we find the relationship that sine alpha over a equals sine of beta over b. So that's a relationship now not dependent upon h1 or h2, only dependent upon information in the known triangle. So let's go ahead now and focus on the bigger triangle right here. So the much bigger triangle that I created here suggests that sine of alpha is going to end up equaling h2 over c. And then I'm now going to look at this triangle right here. Now, what I'm missing so far in this triangle is the angle here. And this is going to be pi minus gamma. Notice how they're supplementary angles. And we need to make sure that everybody's clear on this. When I talk about angles of a triangle, there's only 180 degrees in a triangle. So I know that the angles in a triangle are going to fall in the unit circle in either quadrant 1 or quadrant 2. And if you'll notice, in quadrant 1 or quadrant 2, sine is always positive. So we're able to work under the connection that sine of pi minus gamma is going to be the same thing as sine of gamma. So again, I described it geometrically. I would encourage you to draw a picture and convince yourself of that in quadrants 1 and 2. And you could also then, of course, use your sign of a difference identity to confirm that, but I don't know that we need to go that far. So what I'll go ahead and say now is that sine of pi minus gamma is going to be h2 over a, which we just said was sine of gamma. So solving both of these for h2, h sub 2 equals c sine alpha, h sub 2 equals a sine gamma. Setting them equal, c sine alpha equals a sine gamma, and therefore sine of alpha over a equals sine of gamma over c. So there's another relationship. And then kind of tying it all together, we can see that since sine alpha over A is in both, then by the transitive property, sine gamma over C must also equal sine beta over B. All right, so in this first example here, we'll take a look at, we're solving the triangle. We're given beta, alpha, and B, and that means it's up to us to find gamma, A, and C, the three missing parts. Now, it's easiest to find gamma in this case, since you're given two angles already. We know that there's 180 degrees in a triangle, so if we take 180 minus the given beta minus the given alpha, we find out that gamma is going to be 54.7 degrees. So now, to find A and C, we'll have to use the law of sines. And so I'm going to use as much of the given information as possible. So it looks like I'll use the betas and the b's as much as possible here. So let's see, sine of beta over b and sine of alpha over A can be used, and by plugging stuff in now, this will allow us to find A. So sine of 94.7 degrees over 3.9 equals sine of 30.6 degrees over A. By manipulating this algebraically, we find out that A equals 3.9 times sine of 30.6 degrees over sine of 94.7 degrees. So again, just a little bit of algebra there to clean that up. Punching this in a calculator, we find out that A equals 2.0 if we go to one decimal place, so 2.0. Okay, now for C. So we'll do something pretty similar to find C. I'll start with my given information here of sine 94.7 over 3.9, and now I'll have to set that equal to sine gamma. The found gamma angle was 54.7 over C. So C is going to be 3.9 times sine of 54.7 degrees over sine of 94.7 degrees. And similar to the last one, punching it in a calculator, we get C to equal 3.2.